Hello, my name is Paul Norris. I'll be doing project four, part one. My group mates are Ariana Rodriguez and Jadon Riley. I'm going to be responsible for getting the velocity contours, pressure contours, the plots, all of that stuff. Part one. So first things first, going to want to open up our geometry as usual. Go to the XY plane, and we're going to want to create a circle. Next, we're going to go over here to our dimensions. Check what our dimensions going to be real quick. It's going to be 1 meter. All right. And then after that, we're going to want to draw some lines. Real quick, zoom in. Rectangle around this. Like a square, but I'll change the dimensions after. Bang. Then we're just gonna go back to the dimensions here. This to be bang that out the way. U11, we're gonna have this as 15 meters. We're gonna have this as 7.5, and this one is 15 also. Last but not least, 7.5. Then once we do that, we're gonna want to apply a surface here. So concept surfaces from sketch. Apply. Probably do that is just select sketch one, apply. Oh, generate. Bang. This is how it's gonna look like when it's done. I should save the project. that we have that, next thing we're gonna want to do is open up mesh. So this is how our sketch is gonna look like. The mesh, we're gonna want to insert a method. Apply. And we want to switch it to triangles. Next thing that we're gonna want to do is insert sizing. Like this. Click apply. Switch it to number of dimensions. We want to do about 200 divisions. Growth rate default. Soft. So what we want to do is insert an inflation. Y. Bang. Now this is how the mesh is going to look like once it pops up. Everything looks perfect. Captures everything. Next thing we're going to do is create name selections. Create a name selection. For this one, we're going to call it the wall. Then the outside layer, we're going to call it velocity inlet. Let's call it inlet. Here we're going to have pressure outlet. Then for the top and bottom, we're just going to name it the symmetry. That's all good. We see the inlet pressure outlet symmetry there. Um, and mesh looks proper here. So we're just gonna save project here. Update the mesh here. Then we're gonna wanna open up the setup. Just wait for this to open up. First things first, I'm gonna go to methods. Just make it simple. Pressure to presto. Then let's go to modules and viscous. All right. Then when we're here, what we're gonna want to do is make it in viscid flow. Apply that. So we have that. We want to go back to our boundary conditions. Pressure outlet. Invi- velocity magnitude is going to be 5, which is given. Project. Right there. 5 meters a second. Apply on that. Just going to close this out. Next thing, we're going to want to go to initialization. Initialize. So we run these are all our calculations down here. Let's go to run calculations. It's 200 number of iterations. Let's calculate. Our graph is going to look like. Our calculations are complete. So we have all the info right here to write. First things first, now we're going to want to create velocity contours with streamlines for all cases. So the first one we wanted, just gonna call it GT to velocity magnitude. Perfect. And then we want to select all. It's about right. Just save and display. Now it's gonna look like when you zoom in. It's perfect right there for velocity magnitude contour for it. Perfect. Now that we have that saved, go to our path lines. Skip, switch to 50. Select all again. Make sure everything else looks right. Let's display this. Bing. These are the theoretical results. Everything looks good. Save another screenshot of this. Save. Path lines. Just close, close, close. This back. All right, so now it's all the same color. So figure this out real quick. Gotta go here to save. There we go. So now you can see the curvature around the circle, which is good. Real quick again. Perfect. Now we're gonna want to create another contour here. Go into pressure, static pressure, perfect. I'm gonna select all again. Display. This is what static pressure is gonna look like. It looks good. Have our high static pressure at the stagnation point, so it's matching the theoretical results. This one again. Static pressure. Bang. Now that we have that, I'm gonna create a new contour now. I'm gonna do pressure to dynamic pressure. Pressure to dynamic pressure. Sure. Display. Bang. This shows where the velocity is high. Everything looks good. Now we're gonna want to do a pressure, total pressure one. Select all again. Display. This looks perfect. Is right. So that's all our pressure contours for the first case. Next thing is we're going to plot the velocity distribution on the surface of the cylinder. So we want to go to plots. Y plot. Call it velocity, surface. See, velocity of magnitude is what we want to do here. Do it with the wall. Save and plot. Perfect. This is very symmetric, which is exactly what we want. So it looks good. Gonna want to do here. Good with that. Perfect. Next thing what I want to do is write to file. All right. Now that we have that, let's go back to our viscous. If you want to switch it to laminar. Well, let's go back to our boundary conditions. Let's go check out our inlet. Switch it to 1 meter a second. Apply that, close that. Let's initialize again. Bang. So we got some interesting values here. Run calculations. Perfect. Calculations all complete. Got our velocity contour display. So if we look at our velocity contour here, it's showing that there's some separation. So we'd expect it's laminar, low Reynolds number. The wake should be large. Um, so that looks proper. That's fine. Suppose, and we're gonna do this. Let's display the path lines too after this. Okay, display. Ooh, this looks freaky. All right. This is also showing the large wake region, which is what we'd expect. Um, Bang, we have that. Let's go to our scheme. Bang. Our scheme is looking again. It's a little difficult to see, but you can see the path lines are following the velocity trends here. Now that we got all of that information, we're going to want to go back to our contours and view them. Right here, display. This is a pressure this is a static pressure. Just look right. Shows where the pressure drops right here. Stagnation points. Front back. Better dynamic pressure. It speeds up where the velocity increases, so it's opposite of static, which is good. Right here. It is last but not least, we have our final contour, which is our total pressure, which shows the change in dynamic pressure too. It's good. So that gives us all of our pressure contours. And now for let's look back at the XY plot. Let's plot this. Laminar flow with no slip condition. It should be 0, so this is actually good to see. That's perfect. File. Least go back to viscous and make it to transition. This is T4. Bang. And we want to switch back our velocity magnitude to 10 here. Click apply. Close out. Let's initialize this. Bang. Those initializations. Calculations again. Calculate. Finish calculating. Once this is done, I'm gonna do the same exact thing. Look at all of our contours. Once again. Display. There's a contour for velocity. Let's look back at our path line. Display. Path lines show some vortices and some separation. Again, which is good. Again. And there we go. They're mirroring, which is where the separation occurs. Zoom in. They slowly shape around it. Which is good. Go back to our contours. Just gonna display them all. Looks nice. Shows the stagnation pressure at the end, but we don't have some at the front. It decreases, it goes around the circle. That looks good too. Next thing is dynamic pressure. Let's display this. It's the opposite of our static. Mirrors once again. So that looks good. And then our total pressure. It shows the difference, which also looks good here. Anything to say? So now we have all the pressure contours. We'll go back to our velocity plot. At 0 due to the no slip condition is expected for both laminar and turbulent, so that matches our expected results. Once again, this just going to pull these into Excel, put in all the screenshots, the report. That's about it. Everything else looks fine, and that's it for project 4 part 1. Thank you.